Fundamental chemistry in the contemporary society. Welcome to this resource of Karazin University, one of the oldest classical universities in Eastern Europe. Chemistry has been teaching within its walls from the very first day, for more than 200 years. Authentic universities teach, first of all, fundamental disciplines. Accordingly, spatial and temporal scales provide a proper insight. Today, chemists can operate with a single molecule and even with a single atom. This slide shows three popular illustrations of the capabilities of scanning tunneling microscopy. The logo of the IBM Corporation is made from xenon atoms arranged on nickel surface. The so-called carbon monoxide man is constructed from CO molecules on platinum surface. Iron atoms positioned in a special way on copper surface produce quantum corals. Chemists are interested, first of all, in examining separate molecules adsorbed on various surfaces and in manipulating with such molecules. Two following examples illustrate this. One possibility is to take a carefully prepared metal surface, to place an examined molecule on it, to situate the tip of the scanning tunneling microscope above this molecule at an appropriate height, and to arrange the electric chain between the tip and the surface. If everything is properly adjusted, two potential barriers for electron will appear, one on the tip and the second on the molecule. The space between them is a resonator, actually non-resonator. An electron trapped in this resonator can pass through the molecule to the surface only when in resonance with one of molecular vibrational transitions. As a result, the dependence of the tunneling current on the applied voltage will give the information about the vibrational spectrum of a molecule. This will help, in particular, to understand how these adsorbed molecules will react with a different adsorbed molecule. One more possibility is to selectively broken a chemical bond. It is also possible to bring two molecules together in a proper orientation and to make them react with the formation of new molecules. The next slide illustrates this. The first step is to place two molecules of iodobenzene in the proper orientation and at a considerable distance from each other. Then the iodine atoms are selectively detached. About science in general and about chemistry in particular. Let's ask the all-knowing Google. In response to the inquiry, does chemistry demanded in the contemporary society, this fantastically efficient search engine kindly suggests more than 6.5 million results. Answers for every taste can be found among them, from extremely negative to strongly invigorative. Chemophobia is an unavoidable part of our present-day life. Its adherents will not miss a chance. For me, the bonfire is a fascinating, romantic example of the spatio-temporal self-organization of a chemical burning reaction. It is worth noting that such spatio-temporal organization is one of modern trends in chemistry, and not only in chemistry. We will meet it again. Domestic gas burner is deprived of this fascination. Nevertheless, this is a related but much simpler example of the burning reaction of hydrocarbons, mainly methane. In this case, it is easy to write the chemical reaction. This reaction, which you see at the upper part of the slide, is apparently simple, but later we will see that it is simple only at a first glance. Many people use this reaction for heating houses and mills, but only few of them recognize two important things. First is that the burning of natural hydrocarbons is the most large-scale chemical process of the technosphere. It provides nowadays about 80% of the world energy consumption, which is estimated to be more than 500 billions of gigajoules, or 20 billions of tons of the oil equivalent. This includes industry, transport,